Principal Sir, for facilitating this program. Secondly, I thank my HOD Sir and faculty members in my department who gave me an opportunity to come over here to cover this dice. This dice to me is very special. Why is it special? SP College was established in 1905. It is the year in which Mr. Albert Einstein succeeded in demolishing the universe created by Mr. Isaac Newton in the 17th century, creating a universe of his own through the creation of his special theory of relativity. So SP College is special. It reminds me of special relativity. SPCNs are special. Now, before starting my talk pertaining to today's program, a little forward to my work. Dear students, the biggest issue of any program of this kind in our part of the world is that the audience most of the times is not interested and motivated. So I need to motivate you first. Mr. Richard Feynman says, knowledge is not free. You have to pay the attention. So please pay the attention. It is very difficult to talk sense. Very difficult. Not anybody's cup of tea. Sense is missing. But not impossible, that is important. I can assure you that after the culmination of this program, when you leave this auditorium, you will be a different person. A different person. I repeat. Richard Feynman, one of the greatest teachers humanity has ever created, says about himself that he was an ordinary person. Ordinary person. He just worked hard, and that hard work made him Mr. Feynman we know nowadays. Like Feynman, you need to work hard. You're not, we are not, any less than any talented person ever lived. You can understand any equation, any tensor relation, it's up to you. I don't believe in this, that we cannot figure out the thing which has been figured out by some great person like Kurt Gödel, like Charles Babbage, like Claude Shannon, like Albert Einstein. You can be future Albert Einstein. Achieve that. Now let me begin my talk. But in my talk there is one caution. Don't look at my talk piecewise. Please see it as a whole piece. Whole piece. So I start now. Why space exploration? Why should any country or state spend the hard-earned money of its taxpayers on space exploration? Is it justified to spend money on it? It is justified, and I am going to justify it. You will understand that it is justified. So let me justify it. Now I will use my PPT. So first thing, universe is very vast, very vast. Now I will give you the indicator of its vastness. Number of galaxies in the observable universe, observable, that much universe which we can observe. Number of galaxies in it is between 100 billion and 2 trillion. This is our knowledge right now. We believe that there are between 100 billion and 2 trillion galaxies in our universe. You know, billion is 1,000 million. Million is 1,000, 1,000. I want you to understand it. And I believe you can understand it. And trillion is 1,000 billion. So now, number of stars in an average galaxy is 100 million. Galaxies have different sizes. Some galaxies have more stars, some galaxies have less number of stars. Now you take the number of stars in an average galaxy, it's 100 million. Million is how much? 10 is plus 6. 1,000. So I can calculate the average number of stars in my observable universe. Now if I take the lower limit, that means if I take 100 billion galaxies in the universe, observable universe and calculate, it's a simple calculation. You can take a pen and multiply. There are average number of stars in the observable universe, that is 10 raised power 19. 1 and 19 zeros. So we have 10 raised power 19 average number of stars in our observable universe. Now the number of seconds in a year, is 3.15 into 10 raised power 7 seconds. That is 3153600. This much is the number of seconds in a year. Now see the vastness of this universe. Suppose you want to count the stars in the observable universe and you start. If you start at the rate 1 star per second, you start it now. At the rate 1 star per second, if you make a calculation, then it will take you 320 billion years. Just counting. If you count star and you take 1 second to count 1 star, to count the number of stars in the universe, it will take you 320 billion years. Now if you become smarter, you say, I am going to do it fast. You take only 1 microsecond. That means 1 millionth part of a second to count a single star. At that rate, it will take you 320,000 years. So this gives you indication of the vastness of the universe. There are many, it is just a counting, no details. See how much time is required. This is one piece of my, then I will connect these pieces at last. Second piece. When we are born in this universe, when you are born, everybody is born. कोई भी बच्चा जब घर में पैदा होता है, आप देखते हैं, what happens to him or her जब उसको ये समझो उसके सामने कोई डेड बॉडी होती है, उसको पता लगता है एक चीज, क्या लगता है, उसको डैडी बोलता है ये अब नहीं आएगा, ये मर गया, वो पजल होता है, परेशान होता है, ये उसको समझ नहीं आता है कि व्हाट इज दिस, ये टेम्पररीनेस लाइफ की क्या है। जब उसको बोलते हैं आप ये स्टार जो आप दूर देख रहे हो सम ये बहुत बड़ा है, उसके लिए बहुत पजलिंग होता है। जब वो देखता है कि अचानक से पत्ते गिरते हैं, ग्रीन से फिर कलर चेंज करते, ये सारी चीजें इसको पजल करती। हर इंसान को, हर बच्चे को, चाहे वो क्रिश्चियन के घर में पैदा होगा, मुस्लिम के घर में पैदा होगा, these are fundamental questions. We are born in the matrix of mystery. Everywhere mysteries exist and nobody has been able to solve these mysteries fully. We will come to know it. So there are some fundamental questions for everybody. Are we all alone? Are we only intelligent beings living on this earth, this spatial earth? No people outside this earth, no human beings, no life, no people who can learn, who can think like us, who are conscious beings of different shape, different features. We don't know. So are we all alone? This is one fundamental question. Second fundamental question is, we know right now that the universe is expanding. Stars are moving from each other. And you know the rate of their going away from each other is proportional to the distance of a star from our Earth. And right now we know that is happening at an accelerated rate. We are living in an accelerated universe. So how it began? You know, one answer to that is, it started with a bang. We call Big Bang. But there are other questions which are unanswered. What before Big Bang? So these are fundamental questions for everybody who have ever lived on this planet. The second piece, keep in this mind. Then third thing, we have some common problems. Some common problems for everybody who lives, whether in United States, whether in London or some far-flung area, some island, some tribe which is far from this technology. Everybody has this problem. There are natural calamities. We experience flood. We cannot avoid earthquake. There are dark rocks. You can have a tsunami. You can have diseases. These are common problems. We have to find the solutions to these common problems. They pertain to everybody. Keep this thing in mind. Then, 6 billion किलोमीटर दूरी से अर्थ का ये फोटोग्राफ है. Now where is Earth? This small dot is Earth.
Yes,
This is Earth.
it is visible.
This is Earth. So when you look at it from this much distance, Earth is this small dot. It is pale blue dot. That's why this photograph is called as pale blue dot. Right? Now see, notice one thing. No flags are visible. No borders are visible. No politician is visible. Nothing is visible. So keep this thing in mind while I'm looking at it. Now everybody, this is our sweet home. From that much distance, everybody who has ever lived has lived on this. Every dictator has lived on it. Every saint or sinner has lived on this. So keep this thing in mind. We are living on it. Keep this thing in mind. What is the status of us in the whole cosmos? We are just a tiny thing. Then, what we do? What people have been doing? What Newton did? Everybody who is concerned with science, everybody who is going in space, or everybody who is doing research in any lab, you can do it. We are connecting the dots. Newton connected two dots. What Newton did? Newton compared the acceleration of falling apple with the acceleration of moon. He saw the connection. He saw there is a relationship. And from that he concluded that the force responsible for this fall of apple is gravity of Earth, and same is the gravity of Earth is responsible for the moon. There is just one thing, that it has a coupled velocity, that it is in orbit. So we say that moon is falling. It's always falling towards the center of Earth, but it's not falling. It's escaping the fall because of its velocity. So he, by that dot, he saw the connection between the acceleration of the Earth, and he was able to generalize, universalize gravity. Before that, people were thinking the local gravity, terrestrial gravity is one, and the celestial gravity is another thing. It's not the same force is responsible. Gravity is universal. So we have been connecting the dots, people have been connecting the dots, and we have reached it right now. You have a mobile phone in your pocket. That has been a collection of connecting dots before by different people. The first observation, if you think about it, was Thames, who observed that. Just like if you take in your childhood, you might have done this activity. You take a scale, then rub it over here, then you see the small paper bits attracted. This small observation was done by Thames, but not with scale, but with a material that's called amber. It was in approximately 300-400 BC that Thales from Greek observed that when amber is rubbed with some material, amber was a material, it starts to attract pieces of straw. This small observation was this minute observation led to the development of your Apple phone. Now you have an Apple phone, but starting thing was that. So what happened? People connected dots, we reach it here. That we can construct this mobile phone, we can send Chandrayaan 3. Now when we connect these dots, we use scientific method, we have no other option. This is the procedure of connecting dots. We question, we observe, we hypothesize, we experiment, then we get some conclusion, we compare that conclusion with the theory. This is the method of connecting dots and reaching to a conclusion in science. For example, how we look at the universe. We look at the universe just like we look at the simple system, simple pendulum. For example, if you take a simple pendulum, everybody can construct it. You take some stone and connect it with some string and start it to vibrate. Now it will take some time to complete one cycle of motion, which we call time period. There is another parameter, that's length of the pendulum. Then there is mass of the ball, mass of this stone you can change. Now you want to understand or discuss this system. You want to question certain things. You want to know certain things. For example, you can ask these questions. How does the time period of a simple pendulum depend on the length of the pendulum? This is a relevant question. How does the time period of a simple pendulum depend on the mass is independent of the mass of the ball. At the start, you cannot anticipate it. So nature deceives us many times. What we think could be the answer, it's not necessarily that could be the answer. So it is independent of the mass of the ball. That means if you hang on some pendulum, whole Jupiter planet, or just a single stone, keeping other parameters fixed, L and G, time period will be same. So this is likewise, we look at the universe as a system. Universe is our system. Some star is our system. Where we ask these genuine questions, then we use scientific method. And this scientific method, how we use it, this scientific method, what is scientific method? The constitution of scientific method was given by this man, Hassan ibn al-Hatham. It is in Europe or Latinized, its name has been Latinized. He is called Al-Hazm. Al-Hazm is regarded as the father of modern optics. His book is Kitab al-Manazil, Book of Optics. It's a big book. Al-Hazm belongs to golden age of Muslim era. He was born in Basra, Iraq in 10th century. Many people name it as the first scientist. Now see what he says. Whenever you do science, this is the constitution of science. Keep this thing in mind. The seeker of the truth is not one who studies the writings of ancients and following his natural disposition puts his trust in them, but rather that the one who suspects his faith in them. You have to suspect me. I may be wrong. This is science. You have to, who suspects his faith in them and questions what he gathers from them. The one who submits to argument and demonstration and not to the sayings of a human being whose nature is fraught with all kinds of imperfection and deficiency. Thus the duty of the man who investigates the writings of scientists, if learning is the truth or is the truth is his goal, is to make himself an enemy of all that he reads. Enemy. And applying his mind to the core and margins of its content, attack it from every side. He should also suspect himself as he performs his critical examination of it so that he may avoid falling into either prejudice or leniency. Keep this thing in mind, you are science students. This is science surrounds around these words. Now next thing, we know very little. Many people have come, they have questioned, like we questioned about this simple pendulum, this universe, this cosmos, but right now we say we know very little about this universe. See, the major chunk composition of the universe, when you see 60% of it we attribute to dark energy. Dark energy nobody knows. No person on earth right now knows what is dark energy. It is the energy impermeating all space. So 65% is that of the whole cosmos, whole universe. Then there is 30% dark matter. So it makes up, that's the matter which we don't know. The overall it makes up 95%. Then there is 4% free hydrogen and helium which is available throughout the space. Then 0.5% of the whole universe is stars. 10 raised to 19 stars only make up the 0.5% of the whole cosmos. Then there are neutrinos, they make up 0.3%. Then we have heavy elements. We are made of heavy elements. All human beings, all plants, they are made up of heavy elements. Our earth is made up of heavy elements. Those heavy elements make up only 0.03% of the whole cosmos we know right now. So more of it is unknown to us. So we need people who can unravel these mysteries, who can connect further dots for humanity. Now before this thing, now I conclude, before concluding, I will tell you why we go to space. We are finding dots. We know we may get some dot in Mars. We can get some dot in Moon. We can get some dot on some other planet. About the whole scenario and that's beneficial to every human being on the earth. Remember, they are common problems, diseases. Potentially, there could be some disease, some virus can wipe out every person on earth. No person can survive. It is a potential threat. Remember, the COVID-19, whole globe was on one plane. We have to stop this virus. So who could stop? Salman Khan? No. Who could stop? Some football player? No. Ambani? No. Nobody can stop. You need a scientist for that, who puts his efforts into that and puts his strength into that and gathers information. So scientists are the real heroes. Nobody can save you from disease. No star. No star. And those stars have to save themselves first. Who will save them? So think about this. So we need people in science. In order to address common issues pertaining to everybody to survive. And we need to unravel this. So I hope I have made my point clear. Now before leaving you, I will give you food for thought. This question. This is a problem, it has many names. It's called the Tower of Hanoi. One name is Tower of Hanoi. In this problem, what we have, in this, you have three pillars or rods along which there are discs of varying radius placed. The problem starts with these discs placed on one particular rod in order of decreasing radius. In this picture, there are 8 discs in this. Now, suppose I ask you, transfer this tower of discs to another rod. Right? So you start pulling these discs and moving. When you move one disc, that's one move required. Right? Now, but I will give you the condition. There are 3 conditions to your movement of this puzzle. One is, only one disc may be moved at a time. Second thing, each move consists of taking the upper disc from one of the stacks and placing it on top of another stack or an empty rod. You can take a disc, place it on empty rod. You cannot place a disc of larger size on smaller disc. Right? Now, the question is, what is the minimum number of moves required to solve a Tower of Hanoi puzzle? That means to shift this whole tower to other pillar if you have 64 number of discs. कितने कम से कम मूव्स लगेंगे इसमें ये टावर ऑफ नॉय के पिलर से दूसरे पिलर में ट्रांसफर करने के लिए? And second question is there any relation of this problem with the game of chess? You know, in chess there are 64 stacks. Is there any relation? What is the relation? Think about that and keep thinking. You are science students, particularly when you are in isolation. People have connected dots by thinking. We are here, we have phone, we have every technology because of thinking. Thinking is not boring. There was a person called Rene Descartes. वो छुपता था लोगों से, वो भागता था, वो छुपता था कहीं पे सोचने के लिए. एक दिन उसको बुखारी से निकाला लोगों ने. ठीक है? Thank you very much.
WhatsApp us? So कितनी कड़वायत सर?
Thank you, sir, for delivering such a thought-provoking talk.
जित करें.
Our next speaker is the visionary leader of nanotechnology, Dr. Srinagar, who will enlighten us on a topic